this problem here, we're going to be out the vertical shift, the phase shift, amplitude, and period. So how do we do that from the graph? Okay. So we're going to kind of work in reverse of what we've been doing already. What's really going to be key is identifying the max coordinate here. In this case, it's pi over 2 and 7, and a minimum coordinate here. Okay. In this case, it's pi, and looks like it's -1. Okay, so we're going to start with the y. So I talked about this the other day a little bit, and for the y we need vertical shift and the amplitude. So I'm going to start with the vertical shift and make sure you understand the difference between them. Vertical shift is a location, it's a position. Okay, so identifying where the middle is. The amplitude is a length. Okay, so the amplitude we're going to find by subtraction. The vertical shift we're going to find by positioning, and I'm going to use this property here. So if maybe I'll do it in a different color here, do it in green. If I look at the vertical positioning of this graph compared to this graph, okay, the min and max, we could talk about the middle position here. Where is the middle? Okay, so our vertical shift, we can generalize it this way. It is halfway between the min and max. Well, halfway is a position. And to find the position or average, we can add the minimum and maximum and divide by 2. Okay, that gives us the location of the middle point. So in this case, if I add the two positions and divide by 2, I get the position of y equals 3. So that works out to me my vertical shift. If I look at where y equals 3 is, there it is. Y equals 3 is the middle of that graph. Okay, it's as much above as it is below that position there. This is a really important and useful formula. Okay, that finds the middle. The other thing that we want to find is the distance from the middle to the top, which is the amplitude. The amplitude is a distance or a length. We find length by subtraction. In fact, we can subtract, if I do y min minus y max, or vice versa, here I'm going to go y max minus y min, I get the distance or the difference between those two numbers. So 7 minus -1, the difference between those is 8. So that means that the amplitude must be half of that. So I'm going to divide by 2. So it looks like this. Okay, so this is a generalization that we use. So in this case, the amplitude is going to be 7 minus -1 divided by 2. Okay? And since it's an amplitude, we don't really want the sign in there. So it doesn't actually matter which way you subtract it, because the negative is going to be taken out there anyways. So there it is. My amplitude is 4. So the distance between the middle and the top is my amplitude of 4. Okay, so that takes care of my vertical. What about my horizontal? I want to know the phase shift and the period. I'm going to start with the period. So still looking at my min and max points. Between any min and max points represents 1 quadrant, 2 quadrants out of 4, or halfway through one full period. Now a period is a length, so I want to find out the length between those two positions. So I can subtract positions. So the period t can be done like this. Okay, I can take the x of the max or min and subtract the x of the other. So I did x max minus x min, but it doesn't really matter if I do it the other way, because I'm talking about a length, so I want the absolute value of that. That gives me halfway, so I want to get the full period, I'm going to multiply that by 2. That way I get the rest of the period here. Okay. So in this particular, so that is a generalization. Again, these are generalizations. Those are really useful. We want to make sure we know these ones because we can use these. So in this case here, my x max, I'm going to do min minus max. Not that it really matters, I just want to avoid the negative. So I'm going to do pi minus pi over 2. Okay, that's going to be half pi times 2, which is pi. That is my period. Okay, the period from this point to this point is going to be 1 full pi. If we look at it from half pi to 1.5 pi, yeah, there's 1 full pi for that period. And I can measure that anywhere. I can measure that from the middle to here, but it's convenient to measure it here. And we're using the symmetry again. This is a quadrant symmetry. You know these are 2 quadrants here, so I can just double it. If I only got 1 quadrant, I can multiply it by 4 to get the full length of that. Okay, and again, we're using this quadrant symmetry. Okay, the last part here is working out the phase shift. So I'm going to put a little star here. We want to use cosine when possible, because cosine is easiest. Because the nice thing about cosine is the max is our starting point. The max, so maybe I should clarify this. The x of the maximum is the starting point. Therefore, the horizontal shift in this case is going to be equal to pi over 2. Okay? So I'm going to write that in terms of cosine. So if I want to write that, that becomes my amplitude of 4 times cosine. My period is pi. Well, I better change that into b. So if t is equal to pi, b is equal to 2 pi over the period. So that's going to be equal to 2 because t is pi in this case. So there's my coefficient 2. It's going to be theta minus my horizontal shift. My horizontal shift is pi over 2 to the right. And this works great for cosine. It does not work for sine. Okay, so we have to adjust this and be a little bit more flexible for sine. Okay, and then the vertical shift is plus 3. Okay, we went up 3. Now to use sine, it's a little bit different because we're going to have to find the starting point. So there's lots of options. So I'm not going to generalize things because there's lots of options. Basically, we want this start position, okay, which is 1/4 of a period back from that max point. So 1/4 of a period is going to be 1/4 pi. So I'm going to end up at pi over 4. So that would be my vertical shift, or sorry, my horizontal shift for sine if I want to start there. If I want to start here, the way it's been oriented, this is halfway between those 2 points. Okay, so I could take the average of pi and 1 pi and half pi, or 3/4 pi, or again we can use another quadrant, 1/4 pi quadrant to get there. So there's a couple ways to do it. We could use, but if we use this point, by the way, this is a negative sine graph. Notice it's going down. Okay, and we can do that. It's no problem. We can do that. So we can choose any of these positions. This is going down, this is going up. But we can find these positions relative to the min and max by using the quadrant symmetry. So we have to know the length of the quadrant to be able to move from the min or max 1 quadrant. Okay? And again, we could even start here, but this is just the start of a new period. This is just a coterminal point. So, okay, if you really want to write for sine here, I'll do the sine as well. It's going to be same vertical expansion, same b value, but my shift is going to be different depending on where I'm going to start. This is a positive sign going up in this direction, so I'm going to start at pi over 4, and then the vertical shift doesn't change. Okay, so this is different, right, than if we want to use cos. But if you have the option, use cos. Cos is easy.